Okay, I've decided I should try and work through the review for those of you who are studying on for your test but maybe getting stuck. So we'll start with this problem. I'm going to put all my data into a statlet. Not that statlet, sorry, not that one. Here, let me go find my statlet. That would be, we'll just type it in, www.statlet.com. And I want to use two quantitative variables. All right, two quantitative variables. And for our explanatory, let me go ahead and look at what that was. I guess I should move this up just a little bit so I can see my other. There we go. So I can switch easy. So I'm going to enter all these achievement test scores and GPAs. And what I'm going to do, here we go, I'm just going to move this off the screen so I can see them. And let me do that. There we go. So, test score is the explanatory. Not text score, test score. And I'll do 98, 96, 94. And I'll keep doing this, but I'm going to pause it so you don't have to see it. GPA is 3.5, 2.7, 3.1. So this is a two quantitative variable statlet. I'm going to enter some data. I'll be right back. Okay, so I finished entering all the data and I double checked it. I did have a typo on this. So if you miss something that's pretty simple at the beginning, test something that should be pretty straightforward, go and double check your data. So this one was kind of a pain. Sorry, the data was formatted in a not friendly way. So I'm going to hit begin analysis. All right. And there is our scatter plot. And I'm going to calculate the correlation. Just go ahead and do both these buttons every time. You should not need the dot plot of the residuals ever in this class. Maybe this one you will. All right. So let's go ahead and see what our questions say. All right. I'm going to come pull this through. Compute the correlation coefficient. So here, the correlation coefficient is 0.524. 0.524. The direction, it has to be a positive direction. We don't really have a moderate direction. And then, is it a moderate correlation? So 0.524, if you recall, I gave you the guidelines. If it's between if it's between negative 0.5 and 0.5, it is weak. But 0.524 is between 0.5 and 0.8. That is what we call moderate, all right? So I can go ahead and test this. Sorry, I got to slide. On my teacher view, I have to slide to the bottom so you can see if I got it right or not. Submit for testing. So you want to kind of double check those. Those are good, so that means my regression model is good. Okay. Then it's asking, I'm going to just kind of slide this in. What percent of variability is accounted for by the relationship between the two variables? You're going to find that right here. The r squared, but that's in the decimal form. So you see this number, it's 0.275. Change that to percent. You do not need to put a percent sign in because it's already got one there. Then the slope is the number in front of x. So that's the number I can actually control C. Pop the reason I use slope is I saw the y-intercept. They asked what would the slope be and what would the y-intercept be? Right there. And for every point a student increases their score, what do we predict the change to be in their GPA? That is just the slope, okay? So the slope tells us the rise over run, which means it tells us how much our response variable, in this case, well, what is the response variable? It was GPA. And how much a response variable will go up for every increase in our explanatory variable, which is test scores. Okay. If a student scored a 93 on an achievement test, what would be their predicted GPA? So I need to know this equation, but luckily I got it there. So I'm going to pull this over and get a calculator. I don't need any fancy calculator. Actually, so what I'm going to do is when you type the math in, it'll do it for you. So let me go ahead. I'm going to, student scored 93. What's predicted? So let me give myself a little room here. So we're going to take the slope, 0.0284 times 93 plus 0.6271. And let's see what it says. Didn't like it. So I'll just do it over here. Okay. Oh, there it is. So you can see 0.0284 times 93 plus 0.6271. So we're going to make a prediction that their GPA is going to be 3.83. Don't worry about having too many decimals. If I did 3 on this, it would probably get marked wrong. So usually it's like 3 significant figures is roughly the amount that WebAssign likes. If a student has scored what about an 88? So what I can do, I don't think it'll let me do that. So let's do 88 times our slope, right? 88 times our slope, 0.0284, right? Plus, and then hopefully it'll do that in the right order. We'll double check. And our y-intercept was 0.6271 equals. And we're getting 3.1263. By the way, if this comes back wrong, it could be because I didn't have parentheses there. It should do it. It should do it and wait to add that 0.6271. But if you want to be safe, you can always do that. All right. What is the residual for a student who scored a 93 on their test? All right, let me go. But actually had a GPA of 3.7. So the residual is actual minus predicted. So the predicted for the 93 was this 3.2683, right? So we're going to do actual minus predicted. So I'm going to say 3.7 minus, I wonder if it lets me do that. No. So my prediction was 3.2683. And my residual is positive because my prediction is, because my actual is higher than my prediction. All right. And I need to slide this over so I can see what answer I'm putting in. 0.4371. Sorry, it's a little off screen. 0.4317. 17, not 71. What would you predict for a student who scores 99 on their achievement test? So we are, again, this is not, this is the test scores. This is not the GPA. So we're going to take that 99 times the slope, 0.0284, plus 0.6271. I sure hope that parentheses, I don't need it. All right, 3.4387. Now, why would I be uncomfortable with this prediction? Odds are it's usually this. So I had a really good activity I did with my AP students. I might share it with you guys as another resource. But basically, the highest score on here was a 98. Let me look at my data on this tablet. Let me do that. So here's my data. And let's go to the tablet, the 2 variables. And yeah, it looks like my highest data point was a 98. I mean, it's just outside. So interpolating is when you use it inside. So I'm going to double check that one because that's pretty close on the range. I'm surprised I did that. Excuse me. So let's submit. Let's see how Mrs. Overman did. I haven't done this review in ages. All right. We're good there. Oh, look at that. Because it's outside of range. So it's only 1 above range. So normally you're not that worried about it. But you could. It says, why should you be uncomfortable? And that's because it is outside of the range. All right. Let's go ahead and we'll do problem 2 on the review. The least squares regression line. Here, I'm going to move this. We don't need that scatter plot. Predicts the amount of natural gas in cubic feet per day based on the daily temperature in degrees. So there's our equation. So there's our slope. And there is, so it has a negative direction. I can see that right there. And the correlation. So the report reports that r squared is 0.35, but that's r squared. All right, so this is a tricky one. I'm going to need a calculator. Let me come back here to my calculator. And I'm going to take the square root of 0.35. So let me zoom over here. Where is square root? There we go. Square root of 0.35. I get 0.592. I'll do this. 0.59. There we go. I'll put that in. All right. Now, if I were to hit submit right now, this would be wrong because the slope is negative and the correlation coefficient must match. It needs to be negative as well. Now, this falls again in the moderate section, so it's a negative direction and moderate correlation. So what percent of the variation in y can be attributed to the variation in x? By the way, that's the difference between an AP class and a regular stats class. I almost never use x and y. I usually use the actual words. So I would say the variation in the amount of gas consumed instead of x or y. Assume there's an outlier where someone had the oven and stove on all day in order to prepare the Thanksgiving meal. All right. What should happen to R if this value is removed? Well, let's see. Well, if we have an outlier, that means it's weakening the correlation, usually. All right, it has a large residual. And if we remove this value, we should get a correlation that is stronger. Now, remember, a correlation coefficient is negative, so it's actually going to get closer to -1. All right, so that's it for that problem. Let's see how Mrs. Overman did. Let's see. Voila, voila. Yay! I know some stats. All right, let's get to the next problem. And I'm not needing the calculator too much. For each research finding, decide whether there's evidence of causation, correlation, or both. If it is only correlation, name a possible lurking variable that may be the cause of the results. As the sales of television sets has increased, so has the number of overweight adults. Does television cause weight gain? So, usually, I don't like that there's an experiment. Technically, this is an observation. I'm going to just say correlation. But, let's see. Yeah, I'm going to say having a TV means you have to sit more, and therefore, people who have more TVs are more likely to be sedentary. I like that one. I kind of like this one too. These are always tricky for me. Okay. That TVs do not emit rays that increase fat in the body. Increased prosperity can lead to an increase in both. That's true. Actually, I'm going to go with all three of these. But yeah, I don't think this is my actual question. I don't know. A study in elementary school found that children with a larger shoe size were better readers than those with smaller shoe sizes. Do big feet make children read better? I'm going to say correlation. By the way, I'm thinking that might be causation. We'll see. Actually, you know what? I am going to pause. Okay, so this is definitely not causation. So increased shoe size is correlated with age. Reading ability also improves with age. More firefighters sent to the fire, the longer it took to put out the fire. Does sending more firefighters cause a fire to burn longer? No, that's correlation. Firemen like fires, so they make it bigger. That's funny. Fires tend to be bigger in cities where there are more firemen. Bigger fires, I think it's just this one. You got a bigger fire, you need more firefighters, not the other way around. What does it mean to say that data has a strong negative correlation? The variables in the data have no relationship at all? No, they do. It doesn't mean they're both negative. There is a negative causation relation. Well, it doesn't mean there's negative causation. It just means a linear model is appropriate and the slope of that line is negative. So let's go see if Mrs. Everman got all these right. Hopefully, fingers crossed, we'll see. Okay, so this one I was kind of like, so it was, all of these are correlation. Remember, I was worried about the TVs. I'm going to just say increase. Let's just say that. because that's almost causation. I mean, that's like having a TV means you have to sit more. You don't have to sit more. Who have more TVs are more likely. I'm not sure. So it's either just this one or both these. So let's try that again. That wasn't too bad. These are tricky. Stats is tricky. All right, let's go. Yeah, I think it wants both of these. Let's try that, because it's definitely not the emit rays. I can tell you that for sure. All right. There we go. See, I told you it was either just that one or it was that one too. But you don't have to sit more. So I missed that part. I probably would have gotten it right if I saw have to. You don't have to sit. Okay, so here we have some correlation coefficients. And I'm going to go with the strong. I'm going to just go negative. Which one is the strongest, most negative? There's a negative 0.85. So I'm going to put that one right here. There is a 0.99 is super strong. I always like to take the super strong ones and do this first. And so there should be another up one that's almost as strong. That's probably the 0.90 right there. All right, so we got a weak one that's negative but not too horrible. We'll say that's the negative 0.40 because that's the only other one. This one looks most flat. It looks 0. So that means this one must be 0.5. All right. Let's see how Mrs. Zefferman did. Submit for testing. And should be all correct. So basically what I did on these is, since it was a sort, could I have told you off the top of my head that was 0.99? Absolutely not. So I would never give you a question like, oh, guess that correlation from a picture. That's the hardest thing to do. So here you had multiple choices for which was which, right? And I just started from the very strongest ends, took care of the strong ones. So like negative 0.85, the 0.99, and the 0.90. So I just had to figure out which one was positive. This was the stronger one. That was not quite as strong. And that's pretty much it. How are we doing? Oh, we're almost halfway through. Okay, the graph shows the relationship between the time in seconds it took men to run the 1,500-meter race for the gold medal and the year the Olympics medal race was run. Which of the following describes the association? Click 2, because we need direction and strength. So it looks pretty negative. I'm going to say it's actually strong, okay? That's not even moderate, because if you remember, look up here. This one right here was 0.90, and that's definitely strong. And we look at this one down here, and we're like, oh, that's pretty strong. Estimate the correlation. Oh, I guess I would do that to you, but at least it's multiple choice. Well, it's got to be negative and strong. And this is not too bad, though, because there are only 2 negatives here, and only one of these 3 negatives, but only one of them is strong. So I'm going to stick with the negative 0.9. So I was right. I was comparing it to that one. Actually, I think it looks even a little better, but oh well. That's our estimate. Okay, and then we have something completely different. Determine what is wrong with each of the following statements. The correlation between the Olympic gold medal times for the 100-meter dash is negative 1.37. Well, it has to... Well, it can't be outside. It must be between negative 1 and 1. You can't have a correlation of negative 1.37. Since the correlation between Olympic gold medals for the 800 is actually negative 0.41, the correlation between times for the 100-meter dash. So what they're talking about here is you flip the direction. So on this first one, maybe this one is y and that one is x. So we have hurdles is y, dash is x, and then dash is y and hurdles is x. R should be the same even when you switch x and y. So that's what that question is trying to get at. So let's go ahead and submit. Voila, this was strong, negative 0.9. Yay. All right. Which of the following scatter plots of residuals suggest a linear model may not be applicable? So right now, already this one's popping out to me. I'm like, oh, that's it. Let me make sure my little dots are lined up with the right graph. All right. Everything else looks pretty scattered. All right. Everything else looks pretty scattered. We'll submit that one. So we're up we're already to question 6. And it was right. Of course it was right. Oh, no, more data. So more data, I'm probably going to have to pause while I enter data. Is there a relationship between math SAT scores and the number of hours spent studying for a test? A study was conducted involving 20 students as they prepared for and took the math section of the SAT. So hours studying should be explanatory. Math SAT score should be response. What do we expect? Oh, maybe I don't have to calculate. Well, I would expect positive and probably moderate. Maybe it's strong. I don't know. You know what I could do is I could put the data in. But since I'm allowed a second guess, I'll go ahead and just guess that it's moderate because it's usually not just the hours. The hours spent studying is your explanatory variable. I guess I do have to enter the data because I need to do the equation right here. So I'm going to pause temporarily and go back to my stafflet and enter the data. Here, actually, let me just show you again. So we got, I'm going to duplicate. You can duplicate your tabs, right? So actually, so we have hours studying. And I'll put the data in there. And we have test score, I think. So I'll be right back after I get the data. Okay, I went ahead and entered all the data. And remember, you hit begin analysis. Ooh, that looks strong, doesn't it? I'm going to say strong and positive. I don't even have to look at R. That is strong. Okay, so let's see what our values down here. Calculate the correlation. Definitely see. Confirms 0.934. There's our regression line. Always, good. It hit the dot plot of the residuals. We don't need that. All right, so there are all of our values. By the way, look, you can actually do other regressions, but that is outside of the scope of this class, so we're not going to be doing that. So which variable should go on the horizontal axis? So we already said hours spent studying, and then I knew I needed it for this. So my predicted SAT score, so this is times hours studying, so this is the slope. I'm going to want this number right here. I'm doing Control-C, Control-V to paste it. Nice shortcut. No reason to have a typo from a control paste. Now, by the way, if there was a negative in here, make sure you capture that too. So always look in front if there had been a negative here, or if this had said minus right there, you need to capture that negative. All right. And I would say this is a very good fit because the correlation is greater than 0.9. It's greater than 0.9. We'll never get a correlation greater than 1. What percent of variability is explained by the model? 87.2%. Now, you know what? I'm guessing that I'd leave the percent off. That seems odd. All right. When a student studies 1 extra hour, what do we expect to happen? Well, our slope is 25, so we expect their score to go up by 25 points. If a student studied for 15 hours based on this study, what would be their expected math SAT score? So I'm going to need that equation and a calculator. So 25.3265 times, we said 15 hours, plus the intercept, which was like 353. So if you study no hours, you should get about a 353. All right. I don't think I need this many decimals, but it doesn't hurt. All right, so I'm going to take that 733 point. Honestly, 733 is probably a good enough answer. That's pretty darn precise, probably more precise than reasonable. If they spent 100 hours, oh, that was in the wrong blank, 15 hours, there we go. All right. If a student obtained a math SAT score of 720, based on this study, how many hours did the student most likely spend? So if you are super uncomfortable with your math, here, let me go ahead and just submit these first before I finish this. Almost done, kiddos. All right, let's get those all in. All right, so see, we're so far so good. And these are wrong because I haven't answered them. All right. So interpolate means we're going to go ahead and use the model for data that went through it. So how many hours did the student most likely spent studying? There are a couple of ways you can do it. Maybe if your algebra is really bad, what do we say? They got to score 720. So what you could do is you could kind of run it out to this line, and you could say, we're going to guess 14. I'm going to try it. I hadn't tried this before. Let's see if it works. But I solved it algebraically, so it may not. It may require me to do something else. Let's see. How did it like it or not? I'm going to say not. Oh, look at that. That worked. So you can actually look at the graph. So what I did is I looked at 720 and I said, okay, come over to the line and see how that's hours studying. And so it's like right about, so it's about the same value right here. So this is about 720. It's about 14 hours. Now, algebraically, what you could have done is you're kind of going backwards, right? So you could say you'd subtract the y-intercept, right? So you would do, in our equation, it is the y-intercept is 25, so we want our y-intercept is 353, right? So that should work, right? And then divide that by the slope, and this will work. Should work. Better work. There you go. So it's about 14 and a half. Now, I don't think that has anything to do with decimals. So it could also be rounding. I'm wondering if 14.5 would work. 49. All right. Let me submit again. Let's see. It's kind of far off, 14.49. So I'm wondering if I actually was emphasizing using the graph on. No, that was fine. So I allowed a range of values, all right? So you could have done it algebraically, or you could have interpreted the graph. If one doesn't work, try the other, all right? And then it says, hint, hint, extrapolate data. Warning, warning, danger, Mr. Robinson, if you've ever seen Lost in Space, the old one. So if a student spent 100 hours studying, what would be their expected math score? So I would be going 100 times 25. That would be 2,500, which is pretty darn high, and I think impossible, right? So actually, I'm supposed to do it, so let me go ahead and do it. So we're taking the slope times 100, 25.3265 times 100, and then adding our y-intercept. I'm pretty sure I don't need a decimal. 2885 is our expected score. There ain't no such thing, but we're going to put it in anyways. All right. Which of the following applies? We shouldn't make predictions outside of the original data. And this is higher than the highest possible SAT score. We do not have a lot of confidence. What would the residual be for a student who studied 10 hours and scored a 690? So if they study 10 hours, we go 10 times our slope. Where's my slope? It's over here. Hey, wait a second. There it is. 10 times 25.3265. And then I'll add my 353, which I'm sure is fine. I'm going to 606. I'm going to put in 606. All right. So, and scored a 606. Oh, so 606. So the actual is 90. So let me bring back my math. Let me bring back my calculator. So that's the predicted. So I'm going to say 606 minus, it's got to be the actual. Actual first. Click. They scored a 690. So 690 minus 606. Oh, you can't see my whole calculator, can you? There it is, 84. All right. So did it overpredict or underpredict? So the actual is 690. We predicted a 606, which is under the actual. So we'll say underpredict. And provide the coordinates for the point that appears to be an outlier in your scatter plot. So what we can do is just go to our statlet. Yeah, that one looks like it. 22 and 790 appears to be an outlier, right? See how low that residual is next to everybody else. 22 and 790. Oops. 22, 790. So they only spent 22 hours, but they had a really high, or they spent 22 hours, but they didn't go much higher. Oh, provide the slope of the regression line after removing the outliers. So what we're going to do is we're going to take that 790. Yeah, that looks like it. Doesn't say which two. So there's only 122, thank goodness, and there's only 790. So delete that. And then delete this. And begin my analysis. And calculate the squares regression line. And a correlation. Oh, look, it got stronger. All right. So it asks, provide the y-intercept. The y-intercept is now 313. Oh, and we also want the slope. Slope is, without the x, don't put the x in there. All right. And they're both positive, so I don't have to worry about it leaving out a negative. Yes, it improved because the residual was large. All right, that is the correct answer. That was a very large residual. So if I hit submit for testing, and let's get down to the very end. All right, so the TI, this data, oh, by the way, hopefully I'll give you data this way because you can actually plug this into Staplet. See how you can highlight it and paste it. I'll show you. So if I give it to you like that format, that's not too bad. You can see how often I use Staplet. All right, so see how it pastes in just fine. Pretty sure. Let's see this one. So I'm going to go ahead and throw them in the Staplet since I can actually paste them in. Hopefully they'll paste in nicely. And age and height. Looks like I misspelled height there. All right. So there you go. See how it works? So if your data is in rows, I could probably be nice and fix that for you. Okay, so Pearson's correlation coefficient is, let's see. Considering we do not have the data, oh, all right. So what that means is I got to go look over here. And actually, honestly, that looks strong, right? And positive. I don't need to know the numbers. That's pretty strong. And let's go ahead and look at the correlation coefficient, 0.993. All right. So then we have percent of the variation explained by the height. So the nice part is we can just look at our R squared. You don't need that dot plot. R squared is 0.985. Change that to a decimal, 98.5. What is the lowest residual you calculate for the given set of data? So the lowest residual, I would say, here's the nice part, you can float over it. I got 0.043, negative 0.06 looks pretty, that looks like the tiniest one. All right. Well, maybe, I'm pretty sure if we're talking about close to 0, but maybe they want this one. I think they want that one. Yeah, negative 0.355. And they being probably me. So one of these is the 0.477, 0.507. The highest residual is 0.507. Right? So here's the residuals. Yeah, this is back in the day when we used calculators. The residuals are not increasing within, so a linear model is appropriate, so you can ignore all three of those. There is no pattern. No pattern good, everything else bad. So I'm going to double check these answers, make sure I did those correctly. Oh, the lowest residual, maybe. See, remember I told you, I was like, the way that's worded. And I did it, so I know, sorry. I'm wondering if it's that one, 0.043. No, this one was closer, no, this one's closer, 0.043. Let me put that in. So in other words, like closest to the data. Let's try that. Oh, and I haven't done, I was like, why are those wrong? We're almost done. And I'm going to have to go check on this one. Tell you what, let's cheat. What the heck are they saying? Key. Okay, let's see what's going on here. There we go. Wait, I did have that the first time. Let me go look. Oh, wait. Okay, it must be just a rounding issue. Negative 0.355. That's close enough. All right. And let me go ahead and turn off. Okay, so 357, turn off my key so I don't cheat. Well, that explains it. I was like, what the heck? Maybe I mistyped in a data point and it's rounding. That could be it, actually. All right. Okay. And what is the predicted height for a baby who is 22 months old? So we're going to need our slope. Oh, good. We can just put I can check and see if there's a typo. Is my equation the same? Let's see. 6.4945. That's right. 0.633. Yeah. Huh. Maybe I'm not. Oh, I know what probably happened is these numbers were used and that can just shift it a teensy bit, which can be super annoying. So we need to predict the height for a baby who's 22 months old. So let's go ahead and get to our calculator. We are going to go, all clear, 0.634 times 22 plus 64.945. Okay, so that's our prediction. Just copy the whole number. You're probably going, but that's a crazy number of decimals. Yes, it is. What is the actual height of the 22-month-old baby? So let's go look. 22, 78.8. Oh, that's not far off. See, this is why you want the thing. What is predicted height for a baby who's 25 months old? So here I'm going to go 0.634 times 25 plus what was my intercept again? 64.945. And I'm getting this amount, 80.795. Come back here. Actual height for the 25-month-old baby was 81.3. What is the predicted height for a baby at birth? So that would be your y-intercept, which would be this number right here. Given that the average height for a newborn is 50 to 53 centimeters, what would explain the discrepancy? So according to this linear model, our babies should be bigger. Probably the birth month is outside of the data range used to create the least squares regression. See, we didn't start till 18 months. So that's called extrapolating. Extrapolating bad. Very bad. And which of the following indicate a good linear fit? Anything with a pattern? Bad. Pattern bad. Random good. And that is it. Voila. You should have all your answers right. Okay. And hopefully I explained everything well. Oh, wait. Oh, my goodness. Oh, it asked for the residual. Bad teacher. All right. Oh, they said if the actual height of the baby is 83.6. It helps if Mrs. Overman reads the question. So what we're going to do is take actual minus predicted, 83.6 minus, and let me find out, minus 78.893. All right, 4.707. That's my residual. I was like, I thought I was going to ask for residuals in this problem. Why aren't I asking residuals? Apparently I did. All right, Mrs. Overman can't read her own question. So 76. So for the predicted height was 80.795, pretty much 80.8. But the actual was 76. Always do actual first. Minus, and we said 80.8. That should work. This should be a negative number, negative 4.8. So I'm going to put that negative 4.8 in. Sorry if I confused you on that and you're like, that didn't work. I'm sorry. And let's see. Everything should be green now. Yes. Oh, there we go. Yes, it's all green now. All right. So hopefully that was very helpful. And if you have any other questions about the review, let me know. Remember, you will not need to use a TI. This is from the days when we didn't use Stapplet so much. But you will be able to use Stapplet, and you saw how I used that. And ideally, you would use a regular calculator instead of Google, but I couldn't show you my regular calculator easily on screen. Good luck on your test.